Okay, now let's continue. Uh, let's say we plot this velocity, this t. Okay. Now, if you have this, which is a straight line, that means v is equal to at plus c. Okay. T is the variable, t is the constant. The y-intercept is here. This, let's say, this is a velocity uh, function with respect to time. If I take this dv over dt, so the gradient of this line will be the acceleration. Okay, the gradient of this one is the acceleration, dv dt, if it's a straight line. Okay, so if you look carefully at this is actually the acceleration if the object is travel at a constant acceleration. Okay, if we slant the other, this is for positive acceleration. Okay, now let's say you look at another one, t. Let's say the line is slant this way. Okay, this one, let's say v equal to b t plus c. So this is slanting negative direction. Okay, so this b will be negative. That means to say it is deceleration. Okay, now what about do you have a graph in this way? Velocity. Okay, sorry, this b here is constant. This is a linear uh, line. Okay, so b is constant. That means this one is negative, mean it is a constant deceleration. It's negative. Okay, what about, do you have graph like that? Okay, now this curve here, any one point here, you see that is a constant, it's negative gradient. Okay, it's a negative gradient. That means it's a because it's a curve, so at every one point the gradient of the tangent are different. That means to say the deceleration varies. Okay, if you have v versus t, and the shape of the graph is this way, and this one at this point here, t, the different time at this part of the curve is a positive acceleration. Okay, this acceleration at this point here. Okay, now what about at this point here? At this point here, whereby the velocity become 0. Okay, what is velocity becomes 0? The velocity becomes 0 is at this turning point. Do you see that? ds dt equal to 0. This is the turning point. So if you look at v versus t, these two dv dt, the velocity is 0. Okay, the velocity is 0. So these are the turning point. Okay, when the velocity is becomes 0. How do we refer this? This refers to this point here. Here's ds dt equal to 0, which actually v equal to 0. This is a turning point. So when you have v equal to 0, So these are the turning point. This is the point where the velocity becomes zero. Okay. Then similarly you can plot acceleration versus time. Okay. But the more meaningful graph would be the distance and the velocity. Okay, it gives you more inputs, so you can look at it. Okay. Now, we're gonna do some question on this. Okay.